Hello, everyone. We have explained about SVM and we have seen some theory about SVM. In this video, we want to see that how SVM can be trained on Python. So, as we explained before, for training many models, we can use a package, a skitlearn that we used before for linear regression, and today we will use a skitlearn for SVM. Also, we want to see that on Python, there are many data sets, and we can import these data sets and we can use them. We explained before about iris dataset. Then if you want to import iris dataset can be imported from skitlearn datasets. Then skitlearn can be used also for using some datasets which are downloaded on Python. So then first we will import the skitlearn, then from a skitlearn dataset, we will import load iris. Then when you have load iris, then here you can run load iris, and I will denote this dataset by iris. And by loading this in here, as you can see, this dataset can be imported. Then let me run this, then this one. And also the dataset can be imported. Also, we need NumPy. The NumPy also, can be imported. So today we want to explain a little bit about some other features which can be used in Python. One of them is pipeline. When we use pipeline, see, suppose you have some different tools and you want to use several different tools on your model. You can run them line step by step, or you can run them in one package. If you want to use some tools, and if you want to run all of them in one package, pipeline give us pipeline give us this ability that we can run some different tools in one package. So if we want to import this, again, it can be imported from skitlearn, then skitlearn.pipeline, we will import pipeline. Also, pre-processing is another thing that we can use a lot. As we explained before in SVM, featuring and changing the, scaling can be very important when we are running SVM. It means that sometimes when you scale your data, your output can be much better. Then pre-processing the data that you are using is vitally important. Then in order to scaling the feature, we can do this by using a skitlearn.preprocessing. Then you can see skitlearn.processing. We will import a standard scaler. And this is SVM that we want to use here. Again, from skitlearn.svm, we will import linear SVC because we want to use linear SVM here. Then here, what we want to do, we want to use this pipeline for first pre-processing and after that running SVM. It means that we want to do two things, and yes, as I explained before, these two steps can be done separately. But if we want to do this in one package, then it can be done by using pipeline. So we were talking about standard scaling, and to see that what the standard scaler is, let's see a little bit about iris dataset. In iris dataset, as we explained before, you have 150 flowers, sepal and petal lengths and widths about 150 flowers, and these flowers are classified into three classes. These three classes are denoted here by 0, 1, 2. Therefore, here when we run iris.target, as you can see, these numbers can be seen. Then what these numbers means that the first flower, which has these sepal and petal lengths and widths, here as you can see, this is for the first flower. This line is this number is sepal length of the first flower, petal width of the length flower. This one is petal length. No, I'm sorry. This is sepal length of the first flower. This is sepal width of the first flower. This guy is petal length of the first flower, and this one is the petal width of the length of the first flower. And this flower is classified as 0. And if you want to see what 0 is, here by running iris.target names of these classes can be seen. It means that this flower, which has this feature, is classified as sesota. And same thing for other. Okay, then this dataset, iris dataset, is on Python, and this information can be found. And here you can see some of these property, some of these information can be found very easily on this dataset. Okay, so then here I will consider part of this data set. Here, as you can see, I am running X iris. Iris is the name that I gave to this data set. And here I am considering iris data, means I am considering these features. But when you write this, it means that you want just to consider columns 2 and 3. I want to explain first that in Python, we index from 0. It means that this column is the zeros color. This column is the zeros column, first column, second, and third. Therefore, here when we write our code in this way, it means that 2, 3. It means that first, since this 2, 3 is written after comma, means that we are referring to the columns. If you write this before comma, means that you are referring to rows. Here we are referring to the columns, and we are considering 2 last columns. And this one is our features. And for Y, we are considering then iris target equal to. What this part of code means, we should remember that SVM can be used just for binary classification. Binary classification means that your features are classified into 2 classes. It means that the training data that you want to use must be classified into 2 classes. Then here, as you can see, iris data set consists of some features which are classified into 3 classes. Therefore, since we want to use SVM, then we have to convert this dataset into a dataset which can be used for the binary classification. In other words, it means we need just 2 classes. In order to create a dataset with just 2 classes, we are defining this dataset. This line of code tells us why, capital Y I mean, consists of numbers which are equal to 2 or not equal to 2. It means that for every target value which is equal to 2, this line of code returns 1. And if this condition is not true, it means that for every target value that are not equal to 2, we return 0. Therefore, here, if we run this code, here you can see Y consists of bunch of zeros, bunch of ones. It means that these are target values which are equal to 2. These are target values these are target values which are not equal to 2. These are target values which are equal to 2. Okay, now we have everything. We have X, our features consist of 2 last columns. In other words, these features consist of petal lengths and widths. And we have labels which are binary, with just 0 and 1. Therefore, this data set in this form can be used for binary classification. No, we are using pipeline. Density pipeline, which has been imported, can be used here. The reason that we are using pipeline, because we want to do 2 things in the same time. Here in the first line, we are scaling. In the scaling, we are using a standard scaling. When we want to use a standard scaling, it means that we want to have normal features. When you want to find normal features, as some of you may know, that it comes from statistics, that you will subtract every data point from mean, and you divide this by the standard deviation. This is not important if you have not seen this in the statistics. But then here, when we want to when we want to scale our feature, we can use this standard scale. We have imported this before from the pre-processing. This part is called the pre-processing of your data set. There are many other pre-processing. We will see some of them, but scaling is one very popular one. And another one, the model that we want to use here, as you can see, we are using this name. These names can be chosen differently. Any name can be written here. We are using linear/SVM. And now we are using linear SVC that we have imported. As we explained before, C is the hyperparameter which can be used to coordinate between the length of the street and the number of points that you can accept them to violate your classification. Here we are considering C equal 1. C equal 1 is a small number. It means that we would like to have the widest possible street. And that's a loss function. There's many loss functions can be written here. We will explain more about loss function. That's a very popular loss function. When we run this line of the code, then a model will be defined. And after that, we are ready to train the model. Since SVM is an example of a model which is used for supervised learning, therefore, you should give the feature and labels. Then here, X is the feature, Y is the label. And after running this, then here, as you can see, first, this pipeline will run. Then two things will be done. First, we will run scale. A standard scaler means that we are scaling the feature. And after that, we run this code and we train the model on this data set. Very interesting. And after that, now when the model is defined, then by using .fit training of the model can be done. We explained this before, and this is a keyword which is used a lot in skitlearn, means that after defining a name for your model, when you want to train the model on a data set, this feature .fit should be used. And after you train the model, when you want to predict on this model, then again .predict will be used. This is one new com data. And when we run this here, as you can see, the output is 1. It means that here, if we have a flower with these petal lengths and widths, we can say that our model classifies this flower as class 1. And class 1 means that this flower can be classified in the class 2. And class 2 means that Virginica. Okay, thank you for watching.